Tectonic plates. Plate tectonics. What are plate tectonics? Plate tectonics are defined as the lithospheric plates that are moving across our asthenosphere. And our plate tectonics are divided into 7 major plates along with other smaller plates. The plate tectonics are determined because of the different evidences. So we will be talking about these evidences in the next slides. Plate tectonics. The different forms of plate tectonics are called the plate boundaries. Our plate tectonics are actually the site of seismic activity, volcanism, and mountain buildings. In this illustration, there are 2 crusts. One is oceanic crust and the other one is a continental crust. So basically, crust is also known as lithosphere. This lithosphere is actually floating on an asthenosphere. And since that asthenosphere are made of molten magma, they will also produce what we call a convection cell, meaning to say that the hotter material will rise up, and when they are cooled into the surface, they will also descend back, while the movement actually of the warming or hotter magma and the cooling magma will actually produce a circular movement, and that circular movement is called a convection cell. So that convection cell is the one that is actually pushing our lithosphere, in this case the oceanic crust. And so the oceanic crust is being pushed, and that will converge into the 2 type of crust. One is the oceanic crust and the other one is continental crust. Since the continental crust is much lower in density compared to the oceanic crust is the one that will create the subduction zone. And so this is again the types of crust. One is the oceanic crust, the other one is a continental crust, but both are all lithosphere or the lithospheric plate. So again, that lithospheric plate is the one that moves across the asthenosphere, and this creates our tectonic plates. The 7 major plates are the following. So here is the map of the world along with the different major plates together with the smaller plates. This time we will be mentioning and listing out the 7 major plates. The first major plate is the Pacific plate. The next to that one is the North American plate, followed by the South American plate, and next to that is the African plate. On top of that is the Eurasian plate, and we have the Australian plate, and finally the Antarctic plate. So in this illustration, we will be able to see that the Philippines lies along the Eurasian and the Philippine plate. And so we will also be showing you that the Philippine plate is situated between the Pacific plate and the Eurasian plate. It is between the Philippine plate and the Pacific plate that where we can find the deepest trench in the world. We call that the Marianas Trench. What are some of the compelling evidences that can be found in our planet to back up the theory of plate tectonics? The first evidence that we will be talking about are the earthquake patterns that occurs along the trenches. This is due to the descending plates. For example, in this illustration, we have the Pacific plate and the Philippine plate. So there are earthquakes that occur along those lines. Another one is between the Philippine plate and the Eurasian plate. So basically all of these earthquake patterns are actually creating an outline of the different plates in our planet. And for example, the Pacific plate and the Eurasian plate, that somehow is the location of where Japan is. So Japan is actually one of the countries in the world that has a very high occurrence of earthquake. And likewise, in the Eurasian plate and between the uh, Indian Ocean, so basically there is also a plate there called the Indian plate. So that plate is actually pushing along the Eurasian plate, which created several amounts of earthquake occurrences in there. So that is also where the Himalayas mountain ranges can be found. So that is just one of the evidences that we are going to talk about that will actually provide us a support to the theory of the plate tectonics. And now to move on to another type of evidence is called a paleomagnetism. So basically, if you are going to look at um, the ocean floor, where you can find a divergent plate. So along the divergent plate, there is actually a pattern of what we call a paleomagnetism. These are actually the magnetism residue of rocks that shifts from time to time, and it is found out that along a straight length there are several types of commonality of magnetism, so that occurs in a specific type of rock, and then in another section of the length of the rock is also another type of magnetism that are uniform. So basically it's like a patches of uniform magnetism residue. So that's what we call paleomagnetism. Another evidence that will also support in the paleomagnetism is actually ocean drilling, because this simply reveals that younger sediments are found near the ridge of the ocean floor, and that the older sediments are also found away from that ridge. So another one are hotspots. So underneath the asthenosphere there is some kind of a hotspot that actually is spewing all of this magma, and it also creates those volcanic arcs. So while it's true that some of the islands in the Pacific area are actually having a particular evidence of these volcanic arcs, meaning to say that once they were actually active volcanic islands, and now they are moving actually away from a particular hotspot, and that is just an example that plates are actually moving away from each other or moving closer to each other depending on the type of plate boundary. So these are some of the compelling evidences that actually will help back up the theory of plate tectonics. Plate boundaries. Actually, plate boundaries are created because of the tectonic plates. And what are the different types of plate boundaries? First is the convergent plate. Another type of plate boundary is called a divergent plate. Another type of plate boundary is also called a transform, or better known as conservative plate. So when we speak of convergent plate, this actually deletes crust, while a divergent plate will add a crust. And we will be looking into that one later, so that we'll be able to understand how a convergent plate deletes a crust, while how a divergent plate will also add a crust. So when we speak of convergent plate, there are several types of convergence. One is the ocean to ocean convergence. Another one is continental to continental convergence, and another one is continental and oceanic convergence, or convergent plates. And when we speak about divergent plates, these will create or mid-oceanic ridges and rift valley on land. On the contrary, transform or the conservative plate unlike the divergent and convergent, there is no creation, there is also no destruction of crust. This is when plates will just only move parallel to the different plate boundaries. So we will be looking at the different examples of the different plate boundaries in the next slide. So for this time, we are going to look into how a convergent plate deletes a crust. And so again, the types of the convergent plates are the following. We have continental to oceanic convergence. Another one is oceanic to oceanic convergence, and the last one is continental and continental convergence. When we speak of continental to continental convergence, this type of plate boundary actually creates the Himalayas. For example, our Indian plate is moving towards the Eurasian plate, and this will convolute the land and buckles up into mountain ranges such as the Himalayas. So this is how the convergence of two continental plates such as the Himalayas and the such as the Eurasian plate and the Indian plate that convolutes to create all this grandeur structure in the Himalayas or the Himalayas mountain ranges. And we know that Mount Everest is actually found in the Himalayas. That is the tallest mountain in the world. And when we speak about continental to oceanic, this is a type of convergent plate that has a subduction zone. Example is the Philippine plate and the Pacific plate. And the subduction zone is what creates the trenches. And the example to that is the deepest trench in the world, which is about 11 kilometers deep. And that is the Marianas Trench. Alright, so the continental and oceanic plate also will have the continental volcanic arcs. So we can find all the different features or land features such as these different volcanic arcs. So these are the different islands that we can find, for example, in the Marianas Islands. And most probably it also what creates the different archipelagos such as the Philippines. This type of convergent plate is also a very important geological process that creates the different beautiful land formation in our planet. Now moving on to the divergent plate, this will add crust as was discussed earlier, and in the creation of crust, this will create the land formation such as the Rift Valley on land. So this is how a Rift Valley is actually seen in a particular view from the sky, and actually it has a version also in the ocean. We call them the mid-oceanic ridges. And when we talk about mid-oceanic ridges, this creates the fractures of the ridges, just like a similar version to the Rift Valley on land. However, it is found in the ocean floor. And again, this type of plate boundary will create the ocean floor, so it actually adds a crust into the planet. And so finally, the last type of plate boundary is called a transform or conservative plate, meaning to say that there is no creation or destruction of crust into our planet. And this happens when a plate moves parallel to a plate boundary. So such as in the illustration that is shown here. So for example, one plate is going towards in that direction, while the other one is moving in the opposite direction. So that's an example of a transform plate boundary. And the most prominent example to this one is the San Andreas fault, which is actually a plate boundary called a transform or conservative plate. One is moving towards downwards or in the southern direction, while the other one is going towards the north. So meaning to say that this one is the North American plate and the other one is the Pacific plate. So this is a kind of plate boundary called a transform or conservative plate.